Every year, heavy rains transform parts of Accra into disaster zones. Homes are flooded, businesses are disrupted, lives are endangered. At the center of this challenge lies one of the most important drainage systems in Ghana's capital city, the Alajo-Odaw drain. This is part 1 of YPGG's series on addressing the flood crisis in the Greater Accra region. Today, we focus on the Alajo-Odaw drain, its challenges, and practical solutions that can be implemented without placing unbearable pressure on public finances. The Alajo-Odaw drain collects stormwater from several major communities, including Odawna, Medina, Nima, Tesano, Kanishi, Mataheko, Awashi, and Alajo. Together, these communities contribute enormous volumes of runoff into the drainage system during major storms. During peak rainfall events, the Alajo-Odaw basin handles between 1.35 billion and 3 billion gallons of water every single day. Peak discharge volumes entering the channel frequently range between 59 and 131 cubic meters per second. The drain itself spans 2 political administrations. Construction began in 1999 under President Jerry John Rawlings. The project was successfully completed ahead of schedule in November 2001 under President John Agyekum Kufuor. More than 2 decades later, however, serious operational challenges threaten its effectiveness. The Caprice and Kotobabi runoff problem. Alajo sits within a natural low-lying basin. When heavy rains fall upstream in Caprice and Kotobabi, massive volumes of stormwater rush downhill toward Alajo. The result is predictable. The local drainage system becomes overwhelmed, homes become submerged, families lose property, and livelihoods are disrupted. The situation becomes even worse at the Caprice sand trap. Over time, large amounts of sand, silt, and household waste accumulate within the trap. As these materials build up, the channel loses carrying capacity. Water then backs up into nearby residential areas. But there is a practical solution. Instead of investing millions in large concrete reservoirs, the municipality should identify open public spaces within the Caprice and Kotobabi catchment areas. School fields, parks, and vacant public lands, these spaces can be converted into dry detention ponds. The fields would be excavated between 5 and 7 meters deep and fitted with simple inlet and outlet structures. During heavy storms, excess water would be diverted into these temporary storage areas. Millions of gallons of runoff would be held back and released gradually over 3 to 6 hours after peak rainfall has passed. This approach uses existing public land. It eliminates expensive land acquisition costs, and it protects thousands of homes downstream at a fraction of the cost of major river expansion projects. Another challenge is the Odawna market waste and poor dredging practices. At Odawna and the surrounding market area, daily commercial activity generates large volumes of waste. Plastic bags, food packaging, organic refuse. Much of it finds its way into the drainage channel. The result is severe surface blockage. Flow is restricted. Flood risk increases. Meanwhile, dredging operations face another challenge. Excavated mud is often left on riverbanks to dry. When the next rainfall arrives, much of that material washes directly back into the drain. The cycle repeats itself again and again. The solution is straightforward. The city should install heavy-duty floating trash booms across strategic locations at Odawna and Circle. These floating barriers capture up to 95% of surface waste before it travels downstream. The waste is then guided toward a single collection point for removal. At the same time, dredging contracts must be restructured. Any contractor leaving dredged material on the embankment beyond 2 hours should face substantial financial penalties. Excavated silt must move directly from excavator buckets into line tipper trucks and be transported away immediately. This approach reduces labor costs, improves efficiency, and prevents waste from returning to the channel. Also, the collapsed embankments and metal waste pollution is another critical challenge. In the Achimota-Abofu enclave, Sections of the concrete embankment have collapsed. Without proper protection, erosion accelerates, riverbanks weaken, and nearby communities become increasingly vulnerable to flooding. At the same time, mechanical workshops and scrap dealers operating around Avenor and Lower Tesano contribute another problem. Old tires, damaged appliances, metal components, and industrial waste frequently enter the stream. These materials create stubborn underwater blockages that are difficult and expensive to remove. The answer is not more expensive concrete. Instead, the city should adopt gabion wall systems. Gabions are galvanized wire cages filled with locally sourced rocks. They are durable, cost-effective, and approximately 60% cheaper than conventional concrete retaining walls. Because they are porous, they also relieve water pressure naturally, reducing future failures. To address metal waste dumping, all scrapyards bordering the watercourse should be required to install simple 2-meter chain-link fences mounted on low concrete bases. This low-cost intervention prevents large debris from entering the stream while maintaining business operations. The final challenge we will address concerning the Alajo-Odaw drain is the Graphic Road bottleneck. As the Alajo-Odaw drain approaches the Korle Lagoon near Graphic Road, another problem emerges. The channel loses its natural slope. Flow velocity drops significantly, sediment settles rapidly, and water struggles to discharge efficiently into the lagoon and eventually the sea. During major storms, this bottleneck contributes to upstream flooding. Many cities would respond by installing expensive mechanical pumping stations. But there is a more affordable alternative, a low concrete weir. Positioned strategically downstream of the Graphic Road railway bridge, the weir creates a controlled hydraulic drop. This increases flow velocity naturally, using gravity, not electricity, not fuel, and not expensive machinery. Alongside the weir, small permanent micro-dredges should operate every 2 months to remove accumulating sediment before major blockages form. This proactive approach costs far less than periodic large-scale dredging campaigns. The flood crisis in Greater Accra cannot be solved by a single project, but practical, targeted interventions can dramatically reduce risk. Dry detention ponds, floating trash barriers, gabion walls, protective fencing, low-cost hydraulic improvements. These are solutions that work with local realities. They are affordable, scalable, and achievable. The Alajo-Odaw drain is not merely a channel for water. It is critical infrastructure protecting thousands of families and businesses across Accra. In Part 2, we examine another major drainage corridor and explore the practical steps needed to secure its future. Until then, the question remains, will we continue reacting to floods after they happen? Or will we invest in preventing them before they begin? YPGG, Hopes in Action.